That's so fine. If we're gonna talk a little bit about Galasa here, if you all are into that. How many people know what Galasa is? How many people have used Galasa? Well, the person who knows a lot about Galasa is going to be really helpful here. So, in full disclosure here, you'll see a name on the slide that does not match mine. Louisa Sears, she is the TSC chairperson for this project. She was set to come here, but unfortunately had her travel issues come up. So I'm stepping in to do this. This is not an area of my expertise, but I'm going to try to do as best as I can to go through this. And if you have any questions, I'll try to answer the best I can. The ones I can't, I'll get you connected up with Elisa, and she can help you out. So as long as we're all friends here, let's make that happen. All right. So at a high level, Galasa is really goal is to be sort of a CI/CD integration testing framework, and it comes from sort of the background of ZOS testing. And what's really interesting about that platform is how much of the testing is just done manually there, and a lot of that is just from the historical nature of it. I mean, if you go back to some of these applications, they're going back 3-4 decades old at this point, some of them even more. And back, then that's sort of how you did testing. You had an operator that went through, manually had a set of steps that they would go through, do the testing. Some of that has been improved slightly over time, where maybe you have like a common spreadsheet of tests and each person is going through that, but it's still a manual process. And we actually even see this even off of ZOS as well. It's not a unique thing to hear. I think we just see a higher prevalence of it because of these applications being legacy. But with that, when you're doing manual testing, it's error prone, it's hard to repeat, and it's just costly to do. So if you look at that more even broadly of saying of some of these ZOS applications that maybe part of the application lives on the mainframe, but the other part maybe has a web component or is talking to a cloud service or is leveraging an API from somewhere, you might have testing that's covering some of those pieces because the testing environment's a little bit stronger, the tools are a little bit newer, but the ZOS piece is missing. So if you're trying to do a full end-to-end testing, you end up being back to doing manual testing all over again. I mean, even though you're able to do componentry level testing, maybe for some of the pieces that you can do some more automation on, the whole end-to-end, you're still having to do manual testing to get there. All the things on here are basically the challenges you run into, and none of them are too surprising. It's error prone, it's challenging, the development cycles are really long. So this is where Galasa comes in. And Galasa actually, interestingly enough, comes from being testing within the ZOS space, because for those who are used to ZOS, it has some very interesting peculiarities and how some of those applications were built. So it's designed from that perspective, but holistically, it's designed so it can also tackle testing across multiple different environments and different hybrid cloud environments relatively easily, by also being able to leverage tooling underneath. So, if we look at here with Galasa sort of as your orchestrator at the top end of it, here we have multiple tiers of what your application might have. It might have a web browser front end. You might have a cloud service, for hosting various different parts of it. And then you start to get into some of your ZOS backends and things like that. Galasa is designed to really take care of being able to leverage the various services and tools that you would natively test. So like a browser, you may use Selenium. For a web service, maybe it's JMeter or whatever the platform-specific ones are in there. It leverages and bolts all these together, but it makes it so it's an entirely repeatable process. So that way, when you're testing one of your applications, you're not doing sort of a piecemeal way of doing it where you have some manual, some this, some that. It all can be automated and scripted really well. That's where Galasa comes in, and that's really where its strength is. So if you check out Galasa, and if you go to galasa.dev, you can learn a little bit about the project. One of the nice things it puts in there is a set of basic tests to sort of get you started, because if you have done ZOS development, you probably can realize that how to do testing on it is not necessarily the most trivial thing in all the world. So it comes with a couple really nice tests here, and we'll kind of walk through those as a bit of an example here. And it kind of helps show a little bit of the power of what Galasa can do. So the first case here is looking at what like a mortgage application, for example, can be. And you can see here kind of it's going to have a couple different spaces to it of just like what is a user sort of functional workflow as you're walking through it. So you're starting at a web interface. That data is then driving things into mainframe specific technologies and tools, vSim, JCL. It's using DB2 for doing management. And so you can see here the whole process where you're using the front end of it where it's driving a lot of the interface through the web interface just like a user would. But then at the back end here, it's able to test at these various different layers here at the vSim level, the JCL level, the DB2 layer, and then validate that entire process end to end. So you have Selenium at the front end, you have 3270 batch scripts and tools in the middle end there, and then you have validation that's happening at the back end as well. And a similar kind of thing you can mirror with sort of like a credit account as well. So here's the same thing, generate a number, use this 3270 application, which does your interaction pieces there. Use Selenium on the back end to validate that the web results come through as expected, and then go back and also run that 3270 application that actually validates that side of it's correct as well. So you can see here you're having multiple different layers of testing. You're not just purely testing from a web front end, but you're also saying, here's my web, this is what I'm expecting here, but let me also go validate on the mainframe side through my 3270 terminal what all of those pieces look like as well. I'll pause here. Well, actually, I won't entirely pause here. There's a little bit of a demo here of showing it running, but maybe I'll play that a little bit in the background here. What early questions do you have of kind of some of the stuff I've kind of shown here? And here you can see kind of a little bit of it in action here, how sort of the test rendered is. So you can see here the tests are wrote up in this area here, and then the running is happening on this bottom side. But what questions from sort of your first reactions of looking at it go?
How specific is that 3270 interaction to ZOS? Do you have any idea if you could run a VM 3270 or whatever, right?
From my understanding, you can do that. So it's not specific ZOS. I mean, it's really of like, here's a 3270 interface into what have you system here. So you could probably do like a VSC, for example, just as easily as well. The idea is that just like one of your tooling sets available to you, and then Galasa sort of like orchestrating the whole thing together. But a great question.
John, tell us about the logging on the Galasa side. How can I consume the output of the tests?
So all of it, you can see here, there's like a command line runner that is happening here. So you can capture all the logs as you're running from the command line, and then output those into a log file or what have you there. And I believe it might even also have like a set log runner too. So it's kind of the similar way that if you were running like Selenium or JUnit test or something like that, where as you did the run, you have all of your output of information and then you dump that to log file. It works very similarly here. And you can kind of see some of how some of these logs are coming through the runs, through the console. Does that hopefully answer your question well? And did I answer your question well too, by the way? I forgot to ask. Okay. So yeah, so you can see here a little bit of how the testing infrastructure ends up working. If you're used to doing any sort of back-end unit testing, functional testing, this looks very, very, very similar to it. But as you can see, it orchestrates off the various tools that might make sense depending upon what the testing back-end environment looks like. So how much longer do we have on this video here? There's quite a bit, but maybe I'll skip ahead and we can come back and look at this a little bit later. So. And you can see here that not only do you just sort of have that interface, but it also has an interface that integrates into VS Code. So you can do your testing as a part, if you're already a VS Code user, you can do your testing right there as a part of it. So you can be executing, building your tests at the top end here, having them execute in the back end of the terminal down at the bottom there. And it has sort of this whole full loop how it happens. There's two methodologies of how you can do it. You can do sort of at a local level, so you're doing your testing out on your local machine. But then you can also leverage like an entire Kubernetes VM environment so that you could be doing your tests on a local, you could be writing your tests locally here, but then submit them out to a larger test running environment, get those tests and have them query them back to the IDE. So that's kind of helpful if you have a really, really large application, which would be very difficult to simulate entirely locally. You can push that out to a larger host environment, run those tests there in a much more efficient, system, and then bring it back. And you can do the same thing if you're just having a regular CI/CD pipeline as well. So have it, remote all the tests out to an appropriate host environment, and then get the results that come back, from there as well. So you can kind of almost separate out your tiers of testing, which kind of very similar to like a Jenkins or a tool like that, where you can, have different sort of nodes and whatnot. Any other questions sort of at this point? I have one or two more slides, but. So being that it's a very ZOS native tooling, it has a degree of managers there that understand sort of some of the main flows for different types of applications. So you can see there, it has ones that are very used to on the ZOS side, so file manager and batch manager and common manager that are kind of for your core. But then you have ones for specific tools like CICS or DB2 or WMQ as well. That are designed for interactions that might be with specific products, that you might be using on your mainframe as well. And you can also extend that as well. So you could make a manager that maybe targets your application specifically, or maybe you have a third-party application you'd want to do testing for. You can easily build that from that. And then the third sort of layer of those are all those additional ancillary ones there. So if you're running Selenium tests, you're running JMeter, if you're running Docker Manager, all those sort of other sort of tests there that might target other platforms, you can still use the same manager, tooling and interface, and then it will call those out. And chances are good as you're going through the development, you'll probably be building more and more of these out because you're going to have different tiers of things you're going to be interacting with. And the vision really of this project, and this is a project that, it's in production use. It came out of IBM. Like I said, it was originally a project really targeted at ZOS testing, but they've expanded the scope quite a bit. It's being used by several large mainframe customers globally, which was actually one of the big pushes to bring it into the open mainframe project, is they said, we want to see this, this tool grow, but the way we want to see it is through sort of an open, neutral governance, because we want to help take part in help driving this forward, and we want more of the mainframe industry to start to adopt it. And this is sort of the vision, was really the alignment part of here. It's already hard enough to do testing. How can Galasa be that tool to help simplify it across a mainframe thing that also brings in sort of the hybrid cloud, so you sort of have one tooling that can stretch across the whole thing. And that's really what the main focus of Galasa as a tool is. So that's all the big things I have here. I realize I plowed through slides very quickly here, but what questions do you all have about what this can do? What are some of the use cases, things of that nature? What questions can I help answer? Go ahead.
Question about scalability and load testing. Does Galasa let you do any type of run lots of tests all at once to see behavior? One test is going to succeed, but 1,000 tests are going to hit some choke points.
So it's designed, from the way I've understood a lot of this is, your initial scaling obviously limited by your workstation. So the idea of being able to push out into like a Kubernetes, test environment is your sort of way of like, how do I load test all of these, multiple things happening at once? So you can have several pipelines that are sort of pushing in here, or push like a whole battery of tests through it, run them up on a remote machine there, or run this on this remote, Kubernetes cluster, and then get that whole battery of testing back. And again, with the individual testing, tooling that might be under the hood, like a JMeter or a Selenium or things like that, there have some degree of concurrency and things that you can do there as well. So you can take advantage of what those tools provide. But the nice thing is, because you can query, you can start your testing and kind of orchestrate it from one location, and then push it out onto like a cluster that sort of mimics what your production use is looking like. That's sort of the target of being able to answer or be able to handle that sort of situation. Does that kind of help? Good. How many of you all are doing ZOS testing right now? 2 of you, that's awesome. What are you doing today?
Well, we're in system test in IBM.
Okay, so you're doing the real stuff.
We actually don't use Galasa.
Oh.
It's incredibly accurate.
Well, I happen to know someone. What are you using for testing right now?
We just got Zoe about a year and change ago in our test labs.
Okay.
So, expanding on
Okay.
Yeah, it's for other operating systems and some internal stuff, right? That 3270 interaction is pretty critical, right?
Yeah. Yeah. Yeah, the nice thing is it kind of is able to emulate a lot of those pieces really easily.
Right.
Yeah.
Struggle with it.
I could understand. How about you? What are you using? Are you doing any sort of like automated testing at this point, or nothing really, or?
So we're on the same team.
Okay.
I use Zoe. I don't do the testing myself, but I automate like green screen methods of testing to make it
Yeah.
comparable and faster.
Got it. So yeah, so this could definitely be probably a tool that could be really, helpful for scaling some of that stuff out really well, yeah. Any other questions, folks? If you have deeper questions, I'm happy to get you connected to Louisa. She's based out of IBM Hersley, and she's a really good resource to kind of helping understand some of the other use cases, because they've done a lot of big deployments of this over the years. Go ahead.
Tell us about the community around this project now. So IBM, and you mentioned some others. Tell us about open source.
So it was predominantly an IBM project coming out of there, but there was a couple IBM customers that were starting to do some initial contributions to it, which is what began to push it to be, hey, we need to move this into more of a neutral body to drive that. Since then, there's been some interest from a few other vendors. I think Broadcom had some potential interest in getting engaged in the project to do some testing work. We have another project, an open mainframe project called COBOL Check, which is a unit testing framework specifically for COBOL. It's kind of like one of the only ones out there that does that. And there's been some conversations of how do they integrate COBOL Check into this, so that you can also do COBOL unit testing level things and orchestrate it in here as well. So there's that community that's coming in. That community has bank data in the Netherlands and a few other end users as well that are doing some contributions there. So it's a smaller community, but we're starting to see some early diversity just based upon a lot of users really stepping up and saying, hey, these are the things that we need are really valuable. But excellent question on the community, because that's sort of the lifeblood of really where these projects, grow here, is like, what does the diversity of that look like? Any other last questions? Otherwise, we've probably finished up the only talk of the day that finished up earlier on time. Not that I'm here to judge.
So John, you just mentioned 2 projects under open mainframes.
Yep.
Others that the audience might want to be aware of?
Oh yeah, we have a lot. You've probably heard of a little one called Zoe, which I think you all are using on the automation side. And Zoe kind of could plug into this as well, because Zoe has, we actually see a lot of use cases where Zoe is used for CI/CD automation because it has a great command line interface. So if in a build pipeline you would need to go out and do provisioning or count creation or other sort of interactions with COS services, Zoe can be kind of stuck in there to do that. I mean, Zoe is designed to sort of be the Swiss Army knife of like, how can I access a mainframe more modernly through like APIs and things like that, but it plugs really, really nicely into this use case. On top of that, there's another project which might be also kind of interesting, and there's called Feilong, which is designed to do ZVM guest provisioning. So people who have been doing Linux ZVM provisioning a long time probably remember tools like SMAPI, which if I say it around the right VM people, they start to shudder. This is sort of designed as, it's actually a Python library. The big use case there is that if you're trying to basically do like OpenStack cluster provisioning and you need to provision out x86 and other sort of guests that way, you could do ZVMs in the same exact way. ZVM is sort of a hypervisor similar to KVM for those of you sort of new to the mainframe space. It has its sort of own peculiarities. It actually it's actually probably KVM's learned a lot from ZVM over the years, because ZVM goes back like 20, 30, 40 years now. Todd probably helped write it. No, I'm joking. Certainly was involved, yeah. But it's in huge use in any big mainframe shops. It's an amazing hypervisor out there. But that project really bootstrapped itself around like, how can we do the automated provisioning and things like that. And again, not doing it from ZVM command line terminals, but being able to do it from like a Python library. So it fits really nicely into that. There's a bunch of other projects in there. We have a COBOL programming course, which teaches you how to write COBOL using VS Code. And actually, COBOL Check got pulled into that curriculum over the summer, and we'd probably anticipate Galasa will get pulled into it as well, so you can kind of have a full end-to-end learning of like what modern COBOL development looks like. There's probably other good highlight ones I should have. What other ones should I talk about? Oh, well, we have Zaro. Zaro's kind of a little bit on the DL at the moment there. Yeah, it was really built around how to collect a library of ZOSMF scripts, but it's one that didn't collect a ton of. Yeah, it had potential, didn't get quite the attention. Joe leads a project called Ambitus, which is helping building out tooling around making it easier to help port open source over to ZOS. So there's a number of tools that that project maintains that have came from sort of various resources there, helping do things like hepsidig translations, all sorts of other, things like that. There's probably a handful of other good ones I'm missing off the top of my head. I think I hit the big ones. Did I mention that one? The COBOL programming course I got. That's okay. One demerit. But yeah, no, it's a great library of projects, and if you look at some of and we have like historical ones like CBT tape, which anybody who's been using a mainframe for a time, you have probably used a tool out of CBT tape. It's actually, we believe it's the oldest open source project out there. Its origins come from Share in the 1950s, where when that conference came together, the whole idea of it was, there was this new IBM computer that had just came out, and all these people were trying to figure out how to use the thing. And this group of sysprogs came together, made an association and a conference called Share, and they literally shared scripts, they shared code, they shared it all back and forth. And this is in the 50s, like this is way before Stallman, way before SI, all that sort of stuff. And then there was a gentleman in the early 1970s that saw all of these scripts and tools and everything floating all over the place, and he pulled them together in a canonical tape and started the release of that. And I think that was in 1970. And since then, that project has been releasing there. So if you really trace back, it's kind of like one of the earliest open source projects out there, way before internet, way before GitHub, way before that. I mean, the way you get the code is you'd send the guy a couple bucks in the mail and he'd send you a tape, which oddly enough, you can still do today. But if you look at kind of the breadth of the projects, it's really focused on the connection between these mainframe apps and services that are a cornerstone of the finance industry and a lot of other industries, and helping them connect them to modern development tooling environments and sort of helping unify enterprise IT. So it was probably a long-winded answer of a question of name a couple other projects, but I'm never known for my brevity. Any other good questions? All right. Well, I'll be around here if you have other questions come up. Otherwise, thank you so much. And if you have questions about the project, I'm happy to get you connected with Lisa.